All right, day 2 on this. We want to talk about, first of all, how you would solve 2 times the cosine squared of x plus the cosine of x minus 1 equals 0. But this time, we're not going to have to do our numbering. We're not going to have to say it's plus n times 2 pi. We're going to be restricted in our domain to say that we are only going to worry about the points between 0, or the places that this happens between 0 and 2 pi. So you don't have to think about all those other possibilities. If we keep rotating around the circle, we're only doing one revolution around the circle, unit circle. Okay, so don't let this throw you off. If you see something like this, think about this being a 2y squared plus a y minus a 1 equals 0. And how would we work with something like that? Factor it, okay? The only thing is it has a leading coefficient, so that throws us off a little bit. We have to remember that that leading coefficient is going to be there. So we would factor this as a 2y and a 1y, right? We're still going to deal with it as cosines, okay? Just kind of a mental picture there, okay? So it will be a 2 times the cosine of x and a cosine of x. But this is kind of a mental substitution to help us remember how to factor. Now, what are factors of 1? 1 and 1, right? But we want them, when we multiply it all out, to have a positive 1 in the middle, don't we? So where do we need to put our plus sign, and where do we need to put our minus sign? We want the plus to be the 2, right? And this is the net result of getting 2. 2 cosine times 1 is going to get us 2 cosine. And negative 1 times cosine will get us a negative cosine. That will give us our positive cosine of x. So everyone see where that's coming from? All right. So this is equal to 0. So we want to check out our 2 cases, what's going to make this equal to 0. So if this is equal to 0, then 2 times the cosine of x will be a positive 1. So the cosine of x is 1/2. Correct. So we have to look at one of the factors. If the first factor is 0, that will get us a 0. And then we're going to also have to look at the second factor. Yep. Okay. So now we ask ourselves, where is the cosine 1/2? Positive 1/2. 60 degrees. So we want to be 60 degrees here. Okay, because this is the point 1/2 square root of 3 over 2, and the x value is always your cosine, right, on your unit circle. Okay, where else is the cosine positive in this one revolution around the unit circle? 300, because everybody is positive here. Sine, tangent, cosine, we want a 60-degree angle down here, and that's a 300-degree angle. Okay, so we can either call it 60 degrees and 300, or in radians, pi over 3 and how many pi's over 3 down here? 5 pi over 3. Okay, it's better to do that because they're giving us our domain in radians, correct? Now we have to work on the other half of that equation, because what would make cosine of x plus 1 equal 0? Yeah. And then we ask ourselves, where is it going to be negative 1 in the unit circle? At pi, because this is the point where x is negative 1. So pi radians. Everybody good there? All right. Next example. Again, we're not having to worry about all the potential revolutions here. They've restricted us to one rotation. Start at 0. You can almost go up to 2 pi, but we're not going to include 2 pi again, right? So one full rotation around the unit circle. Now we've got 2 cosine squared x plus sine of x minus 3. Okay, how does that factor? How do we get 2 cosine squared? Cosine of x and cosine of x, right? Factors of 3? 3 and 1, right? Or do we need to put the 3? What kind of factor? Oh, wait a minute. What's the problem here? We got sines in here, don't we? Sines and cosines. I didn't even look at the second piece of it. Okay? We got sines and cosines here, so this isn't going to work the way it is it? Okay? So what do we have to do in order to get things in terms of just one of our trig functions? So we can't have cosines and sines mixed up, can we? But what is the cosine squared? Yep. And then plus this 3 sine of x minus 3 equals 0. That's the sine squared of x, my poor writing. Okay. Cosine squared is 1 minus sine squared. So we've got 2 minus 2 times the sine squared of x plus 3 times the sine of x minus 3. So let's simplify that. And is it okay if we divide everybody by a negative? As long as we divide all terms by negative? I'm thinking ahead here. That's legal, right? Shouldn't impact the overall result. Okay. Positive 2 times, so minus 2 plus 3 minus 3. Add these up. It should be a negative 1. Hold on, I'm sorry. I haven't changed the signs yet. So 2 minus 3 is negative 1. I was thinking ahead. I'm sorry. I was talking about it before I made that step. Okay? So am I right with my signs from here to here? Okay? So now let's multiply everybody through by a negative so we don't have that negative 2 hanging out. Okay? So we'll have a 2 sine squared minus 3 sine of x plus 1. 5 times that just makes it easier to factor. Okay, so as long as we change the sign of everybody, including 0, we're good. So 2 times the sine of x, sine of x. Okay, The second, yep, all I did was added these two guys together to get that. Multiplied through and then combined. Okay. So we need a 1 and a 1. And we want our result to be negative, because the factors of 1 are 1 and 1. Okay. And we want them both to be negative, don't we? Because our last terms, negative 1 times negative 1, will get me a positive 1. Outsides will get me a negative 2 sign. Insides gets me a negative 2 sign for a total of a negative 3 sign. Okay? So far, so good? Set this equal to 0. Okay? Now that it's equal to 0, take turns and decide what makes this first factor equal to 0. And then we'll also have to take into account the second factor becoming 0. So here, the sine of x will be a positive 1/2. If I skip a step, take the 1 to the other side, divide by 2. Okay? And here, the sine of x will be positive 1. Okay? Your sine is your y in your y coordinate on your unit circle. Where's the sine 1/2? 30 degrees, which is pi over 6. And then in this one as well, right? So this is a total of 5 pi over 6. Okay? So those are our two choices, or two answers there. And where's the sine 1 at? Pi over 2. Because it starts at 0 and it goes up to 1. And it's the y value, that's the point, 0, 1. Always in radians, especially when the domain's given in radians. Okay. We said that it was sine is a half at our 30-degree angle. Okay, when you look at the ordered pair there, the y coordinate is your sine. And we're only looking for it to be a positive half. So you're looking for any place on your unit circle where the sine is, or where the y is a positive 1/2. Down here, it'll be negative. It has to be on there, or we're dealing with some indifference. We're going to be using our 30s, our 45s, our 60s, our 90s for the most part till tomorrow. Then we're going to use a combination of them in order to make it happen. So, okay. All right. So now we're supposed to solve secant of x plus 1 equals tangent of x on this interval. Again, starting at 0, going all the way almost to 2 pi, just one rotation. What's going to make that true? So first of all, what do we have to do? Change it to sines and cosines would make sense. Okay, so secant is 1 over the cosine. And let's bring this tangent to the other side, so we've got an equals 0. Okay, so minus sine over cosine. We could move the 1 to the other side, but when we factor eventually, we're going to want to have it equal to 0. Now, it would be nice if they were all in terms of, or we didn't have get rid of this denominator, right? Or get a common denominator. Okay, or multiply everybody by cosine. Okay, now that we have an equals 0, we can multiply every single term by the same thing. So we don't have to worry about common denominators so much. So let's take everybody times a cosine. To get rid of our denominator. But we're just trying something. Okay, see if it works. So we'll have a 1 plus a cosine minus a sine times a cosine equals 0. Does that help us? Not necessarily, did it? try that. So we're saying if we do that, these two, okay, so you're saying 1 minus, plus the cosine minus the sine all over cosine, okay? Instead of doing this, Austin suggested that we just get a common denominator all the way through. So cosine, 1 over cosine has a common denominator. This one is being multiplied by cosine, and this one already has the common denominator. I'm forgetting my x's here. Because it would be nice if we could get a 1 minus sine, or a 1 sine squared, or a 1 minus cosine squared, right? Because that gets us all into one lovely function, trig function, which is what we're trying to get to. Plus sine minus sine. So if we multiply everybody by cosine, we'll have a cosine plus, but then we end up with a cosine sine again. Where did I get this example from? So it's not working to get them in terms of sines and cosines, is it? Okay. What happens if we square both sides? You get secants and yeah, I like that idea. Okay. So let's do that. If we square both sides, we'll get a secant squared Yep. Okay. I FOILed this out, squared the first term, multiply them together and double them, and square the last term. And then is it okay if we skip a step and call this 1 plus secant squared? Or 1 minus, secant squared minus 1? Okay, secant squared minus 1. Tangent squared will be secant squared minus 1. Okay. Now let's get everybody to one side. You can, as long as it's both sides. When it's just an expression on one side, we can't. But as long as we have two sides of the equation, we can. Great question. Okay. All right. So when we take secant squared to this side, we'll get nothing, right? And when we add the 1 to both sides, we'll have 2 times the secant of x plus 2 equals 0. I guess we could have taken the 1 to the other side. Be easier that way. When I FOILed this out, remember when you square something, you can't just square the first term and square the last term. You have to take secant of x plus 1 times itself. So first times first gets you secant squared. Outside gets you a 1 secant, inside gets you a 1 secant for a total of 2. And then last times the last gets you the 1. I could have. But by the time we're in pre-calc, I'm hoping we can skip a step, maybe. I'm hoping. But I don't want to confuse you. Okay? So if 2 times the secant of x equals a negative 2, then the secant of x is going to be a negative 1. Okay? And then we ask ourselves, where's the secant going to be negative 1 at? Secant is the reciprocal of cosine. So where's the cosine? -1. 180 degrees, which is the equivalent of pi. So it's okay to go down a rabbit hole and try to put things in terms of sines and cosines, okay? Before you realize, wait a minute, that didn't work. More practice will help you get there. All right. Sure. All right, last example. I think this is the last one. All right, so now we're going to work with the 2 times the sine of 2t plus 1 equals 0. So first step in trying to get our sine of 2t by itself is going to bring this 1 to the other side. And then we're going to divide both sides by 2. So now the sine of 2t will be -1/2. Okay, so if the sine of 2t is -1/2, we're looking for y values on our unit circle that have a -1/2. Because there's still, that's one unique thing. This is the difference in this compared to everything else we've done. Okay, so where is the sine of -1/2? 7 pi over 6, right? Where else? 11 pi over 6, right? Okay, so when we evaluate this, our 2t will be 7 pi over 6 and 11 pi over 6. But what do we have to do to get t by itself? Multiply by half or divide by 2, exactly. So t will be 7 pi over 12 or 11 pi over 12. This is the distinction. This is the difference in this problem over the ones we've seen before. Right, right. Don't mess with it until you've evaluated. You found the angle who has this sign, okay? And then do the division or multiplication. Okay? The very last step. All right. I think that's it, if I remember right. Oh, I had 1 more, 2 more. Okay. So here's another one, cosecant of 2x. So at the very end, we're going to divide by 2 to get the x by itself. Okay? So cosecant, I'm writing cosine, not cosecant. Positive 2 over the square root of 3, right? If it helps you to find the reciprocal of both, as long as we do it to both sides, we're fine. Cosecant is the reciprocal of sine. Now we ask ourselves, where is the sine, the square root of 3 over 2? Two pi over 3 and now we just have to divide by 2. I divide 2 pi over 3 by 2. Those guys cancel, and I get plain old pi over 3. And if I divide 2 pi over 3, or pi over 3 by 2, I get pi over 6. Last example. See how we're repeating and using a lot of the stuff that we used last chapter? It's a good review of it. Okay. Last one. Everybody's in terms of cosines, right? Okay. Now they want all the solutions, so we're back to not being restricted to one rotation. Oh, was it? I'm sorry. Yep, you're right. All the solutions. Okay. So what do we have to do? We'll add multiples of 2 pi. So pi over 6 plus 2 pi n and pi over 3 plus 2 pi n. Just integer multiples of it, positive or negative. Okay, so again, last one, finding all the solutions of this guy. Now we've got something like 6y squared minus 11y is equal to a negative 5. So always, always, always when you're factoring, bring everybody to one side. And if it helps you to substitute a y in there so you can see how it factors, feel free if the cosines are confusing you. Okay? We know we have to find some multiple of 6. That's going to, with a multiple of 5, add to get a negative 11. So try 3 and 2. If we have a 3 and a 2, the only way to get 5 is 5 and 1, right? So if we put the 5 here and the 1 here, 3 and 10 isn't going to get me 11. If I put the 5 here and the 1 here, 2 and 15 isn't going to get me 11 either. So 3 and 2 didn't work. So the only other way to get 6 is 6 and 1, isn't it? So we're going to try a 6 cosine and a 1 cosine. And let's put the 5 here and the 1 here so we can get 6 and 5, which will get us 11. And the signs of them have to both be negative. Okay? So 6 times the cosine of x minus 5 can be equal to 0, or the cosine of x minus 1 can be equal to 0. Hopefully you're already seeing a problem here. We don't know of any place off the top of our heads where cosine of x is 5/6, right? Correct? So this is where we have to use our second cosine button. Okay, our shift of cosine, our arc cosine on our calculator. Okay? But we do know of a place where cosine of x off the top of our head is equal to a positive 1. Where's the cosine of positive 1? At 0 and 2 pi, right? So 0, 2 pi, 4 pi, 6 pi, 8 pi, right? Okay, so 0 plus 2 pi n. Okay. And then we have to figure out what angle makes the cosine 5/6 in radians. Okay, it's okay to leave them in radians, so make sure your mode is in radians. And then we do a 5 divided by 6, or the second cosine of 5 divided by 6. And we're going to get roughly a 0.586 radians plus any other rotations of that. Okay. All right. So assignment. Let me stop recording here.